Okay, so question number 3. There's 3-point charges located at the corners of an equilateral triangle. Equilateral triangle telling us this is 60, this is 60. All here, the edges here would be 0.5 meter as well lah. We have to calculate the net electric force acting on the 7 microcoulomb punya charge. Okay, force again. Alright, so I'm just going to draw it on the diagram here directly. So the force, this is both positive, so they will be pointing away from each other. And then the other one is attractive force, so they will be attracted to each other. So it's going to be looking like this. Okay, so I like to add an axis so that I can see where the angles are. Okay, but what we could do is we could actually drag this here and just do it this way. Okay, so basically there's gonna be an angle. So the angle 60 degree would be here. Oh, I thought I'm using this one. And here as well. So I'm just gonna label them directly as 60 degree. This is force. Oh, I'm gonna label this as Q1, Q2, and Q3. Okay, so this is force on charge 2 due to 1. This is force on charge 2 due to 3. Okay, so that is the electric force diagram, or what you know it as before, which is the free body diagram. Tapi sekarang ni this is an electric force diagram. Okay, so now back to the steps lah. After lukis diagram, kita perlu cari dia punya magnitude. So what is the magnitude of each of this force? So the magnitude for force F21 is equal to K Q2 Q1 over R21 square. Okay, so this is equal to 9 times 10 to the power of 9. Can I just give you the steps but not write the substitution? Because I think this is what makes it my video a bit more longer, because I have to rewrite it. Not rewrite it, I mean I have to write the numbers. So this is 0.5 square, so calculate the solve it and you will get 0.504 Newton. Okay, and then for F23, do the same thing, just change the Q1 into Q3 as well as the distance, though it's not really a problem because all of the distance is 0.5 meter. And this one you will get 1.008 Newton. 1.008 Newton, yeah. Okay, so after calculating the magnitude, now is the time where you look at it at its own components. Okay, so for the x component, force at the x component is equal to F21 cos 60 degree plus F23 cos 60 degree. So this will give you 0.756 Newton. And then F untuk y component, Fy is equal to F21 sine 60 degree minus F23 sine 60 degree. So why is it minus? It's because this bit here is pointing downwards for its y component. Okay, so that will give you negative 0.436 Newton lah. Okay, so after getting the x and y component, you have to find the magnitude of the resultant force lah. So how do you do it? You use the Pythagoras theorem lah. So fx square plus fy square So this will give you 0.873 Newton. No? Okay. All right. So after calculating the magnitude, remember you have to always determine the direction as well, because force is a vector and it will always have its direction. No? Okay, so there's modulus there, so we are going to ignore the negative, but basically the negative will be telling us whether it's going to be above or below positive x-axis, below, above, ataupun negative or positive x-axis. Okay, so this is going to be 30 degree, and since the y component is negative, which is pointing downwards, and the x component is positive, this is below positive x-axis. Okay, all right, so that is on question number 3, and hopefully the last question for electric force. Yeah, so this is question number 3.